Hi everyone and welcome to Geometry Lesson 3.4a and b. So what we're going to be looking at today is just reviewing the slopes of lines. Because how does this help us? Well, we're going to see when we have parallel lines, sometimes we need to know the slope of them to actually prove they're parallel as well. Especially when there's two of them without a transversal. So the first thing we're going to review is what are these types of slopes? Well, the first one, since it's going up to the right, that is a positive slope. Going down to the right is a negative slope. This one here is a zero slope. And this one is called an undefined slope. And we'll go into that later. So, given a graph, okay, we're going to go ahead and we're going to use the slope formula. Right? And the slope formula, if you remember from a long time ago, was the slope, which is m, equals y2 minus y1 over x2 minus x1. So basically take your two y's and subtract them, and take your two x's and subtract them. So if I look at number 1, I see at this point here is 3, 1, and this point here is negative 2, negative 3. So all I'm going to do is take my two y's and subtract them. So m equals, here's a y, negative 3, minus 1 over negative 2 minus 3. So negative 3 minus 1 is a negative 4, and negative 2 minus 3 is a negative 5. So negative over negative is positive, so the answer to this is 4 over 5, meaning 4 up, 5 to the right. Okay, the bottom number is always to the right. So that means if I were to go ahead and zoom in on this, if I go 4 up, 1, 2, 3, 4, and 5 to the right, 1, 2, 3, 4. I can't count. Right, so 4 up and 5 to the right, that's my slope. All right, let's try number 2. Number 2, now we can count the slope by doing this, right? Actually, we just go up or down first. You go this way and this way, so it'd be negative 3, 6. So let's see if that works out. This point here is negative 3, 3. This point here is 3, 1. So we take our two y's and subtract them. 3 minus 1. All right. I'm sorry, it's 4. 4 minus 1. Look, it didn't look right. Then we take our two x's and subtract them. 3 minus 3. Negative 3 minus 3. So 4 minus 1 is 3. And then negative 3 minus 3 is a negative 6. So this gives me negative 1/2. So down 1, because we only go up or down. We only go to the right on the bottom, always to the right. Up or down on top. So negative means down. So when I look at this, that means I can go down 1, right 2. Down 1, right 2. See how I meet that? Down 1, right 2. Down 1, right 2. So like I said, this should just be a review. Let's look at number 3. Number 3, this is 1, 2. And this is 1, negative 4. So let's take our y's and subtract them. So m equals 2 minus a negative 4. Right? It's always a minus. Doesn't matter what the second one is. And then you have a 1 minus 1. So this is negative 6 over 0. Well, anything over 0 is considered undefined. You can't have anything over 0. So that's why that is called an undefined slope. This one here is 4, 4 for J and 1, 4 for K. So if we do this, we take the two y's and subtract them. 4 minus 4 over the x's, 4 minus 1, so that is 0 over 3. Well, 0 over anything is going to be 0. So this is 0 slope. Right? So basically, we're going to do the same thing over here. Right? We're going to use our m minus y2 minus y1 over x2 minus x1. So all I'm going to do, I take the two y's and subtract them. 5 minus a negative 1 over the two x's. negative 2 minus 6. Negative negative is a positive, so this is 6. Negative 2 minus 6 is a negative 8. So this is negative 6 over 8, which gets simplified because 2 goes into both of these, so negative 3 over 4. And that is your slope. Let's try one more. Take my two y's and subtract them. Negative 3 minus 7 over my two x's. Negative 11 minus a negative 6. Doesn't matter, this is already negative. There's always a minus sign. This is a negative 10. This makes a plus. So negative 11 plus 6 is a negative 5. So this is just 2. All right, and I'll let you try 7 and 8. Right now in this one, we're going to find the slope of the lines. Right, this is your exercise to do. Okay, I'll do one with you. Now, you could do it using the graph if you want to. Just by going, all right, I have to go up 2, and then I go right over here. So up 2, right, 1, 2, 3, 4, 5, 6. So that's, the slope is 2 up, 6 to the right, or 1/3. All right, so you can definitely use a graph for this instead of the formula. But you have no choice when you're given this, right? So like this one, it's, remember your formula, m equals y2 minus y1 over x2 minus x1. So you take the two y's and subtract them. Negative 11 minus 4 over negative 8 minus 17. This is negative 15 over negative 25, which is a positive, right? Because these cancel out the negatives. So 15 over 25, 5 goes into both of them. 5 goes into this 3 times and that 5 times. So that is your slope. All right, so your guys are going to work on those. Moseying along to 3.4, right, what we're going to do is we're going to see how do we use these slopes to figure out if lines are parallel. So the thing about parallel lines, they go like this, right? They have the same slope, and that's how we know they're parallel. If this is 3, 4, this has to be 3, 4. It's the only way they won't touch. So they have the same slope. Now, perpendicular lines do not have the same slope because they perfectly intersect to make a right angle. And we say that these are what's called the negative reciprocal slope. What that means is if I have 3, 5, the negative reciprocal is negative 5, 3. If I have a negative 2, the reciprocal is going to be positive 1/2 because this is really 2 over 1. So you change the sign and you flip the fraction. It's a negative reciprocal. So here's some examples. 3, 4, the negative reciprocal is negative 4/3. This is really 2 over 1, so reciprocal is negative 1/2, like I just showed. Right, I'll let you try 3. Let's do this one, right? So the reciprocal of this would be negative 0, which is just still 0, right? So its reciprocal is itself. But what the problem is that technically, right, this is 0 over 1 when you think about it. And if I were to flip that over, that would be 1 over 0, which is undefined. So technically, the opposite of a 0 slope is undefined. And we can go back up and see that right here. See these? This is your undefined. See how when if you put them together, they would make a right angle. All right. So let's go ahead and use the slope to determine if lines A and B are parallel and perpendicular. So what we do is we find the slope of A. We take the two y's, so 6 minus 3, right? Over the two x's, negative 2. I'm sorry, let's do it in order. 3 minus 6, because it doesn't matter which way you do it, as long as you go in the same order. Negative 2 minus 2. So for this one, this is a negative 3, negative 2 over negative 4, which is just 3/4. So we know that A is 3/4, AB. So let's check CD. Slope of CD is 0 minus 3 over negative 1 minus 3. So that's negative 3 over negative 4. These cancel out, making that 3/4. So this is 3/4 and this is 3/4. Since they are exactly the same, they are parallel. Let's try number 2. Number 2, we take the two y's and subtract them. 2 minus 4 over 0 minus 5. This is going to be a negative 2 over negative 5, giving us 2/5. CD is 8 minus 3, which is a 5, over 1 minus 3, which is a negative 2. So this slope is negative 5 over 2. Do you see how they're flipped over from each other and the signs are different? So these are perpendicular. Right? And that's what we do. Now, if it's neither, then it's neither. If it's not the same and it's not a negative reciprocal, then they're not parallel or perpendicular. They're probably lines that look like this. So I'll let you try some of those. Right? And then we will go over it. Okay.